Thanks for coming today and for your time. My name is David Cottingham. I'm the co-founder and CEO of Airlock Digital. We're an allow-less company where we do basically deny by default security, choose what you trust, block everything else. And I started this company about 12 years ago because it's a really effective thing to do, and I find it really difficult to implement in practice and at scale. So this talk is really about how I think that reducing the attack surface on your endpoints through hardening, particularly removing things like lol bins, is one of the most sort of cost-effective things that you can do in order to reduce attacks inside your environment. So I'm going to talk about a few ways to do that in this session, and hopefully give you some useful practical takeaways in order to start with some approaches. So we're going to be talking about the general ecosystem, why attackers are using lol bins, talk about some defensive strategies and approaches, and also some tooling that you can use. But first, I wanted to start with Windows 10 long-term servicing branch. In 2015, it seems like a long time ago. Well, it was a long time ago. But this was based on the original release of Windows 10, and it's still under patch support for a couple of months, right? Rapidly coming to the end of its life cycle. But you'll notice something in this screenshot. It's very calm. It's very refreshing, because of the lack of things that are there. There's actually not much in this build. It's just the core essentials that you actually need. And I think that somehow along the way we lost a little bit of that. This is Windows 11 23H2 Enterprise. This is the long-term servicing channel was recently released, but this is what a decent amount of enterprises are basing their SOEs on today. And you'll start to notice things in the start menu clipping in, chimp champ. We've got, Cortana that's there, and a whole bunch of other things, which is meant to add value to your everyday lives. And if we take an unscientific approach and start to look at what's actually changed between these builds, so we've got about a 9-year horizon here. We've got about 82,000 files in Windows 10 long-term servicing branch. This isn't a scientific approach by any means. But on the right, we've got Windows 11 23H2, and between these two builds, you've got about a 46% increase in the total number of actual files that are in these operating systems. And it's hard to figure out exactly what the difference is. It's hardly scientific, but it does highlight a significant increase in code. But this is not the long-term servicing release of the operating system. Windows 11 LTSC Enterprise was released in October 2024. And if you're not running the long-term servicing channel, I strongly recommend that you should change your organization to use this, because you can see that it's stripped back a bit, right? It's got some of the features and additions that we don't want. And if we look at what's actually changed between these builds, we've got about a 20% less overall code that's actually in these enterprise releases. So a lot has changed, and still that's quite a large amount of code, right? We'll dive into what type of stuff that is in a second. Windows Server 2025, though, has a non-trimmed down, non-desktop edition, right? However, there's additional things that are being added in. There's new file compression features, which is like you can now compress 7-zip files and tar files. And there's a lot of chasing that Microsoft's doing of the capability that's at your fingertips in Linux, right? That's really, really useful. And also OpenSSH is in there by default. So same with the latest versions of Windows 11. So you've got an SSH server that's there. It's not really an option. It's just binaries on disk that can be invoked. So my argument is really value cuts both ways. As I said, it's great to have these utilities there at our fingertips, but it's also great to assist attackers in lateral movement. You can open SSH, you can exfil data in different formats now. You can compress in sort of 6 different file types. We're not just limited to zip, and that's good and not good. And these features seem to be increasingly being added by default. And reducing functionality is really one of the best bang for buck strategies I think that you can do for securing the attack surface on your endpoints. And in terms of why are attackers using these things, and I wanted to talk a little bit about lol bins, right? Living off the land binaries are binaries that inherently exist within your environment and your operating system to further attacks. And malware sometimes works, but attackers really aren't using that these days because it's really easy to signature detect that. It leaves artifacts behind on disk. And these lol bins really take advantage of the good and the bad file gray area, because as a security vendor, I can't say that a binary is bad if the primary or even a part of the intent of that binary is good. right? Lol bins are both. They're good and they can be used for bad, even though they're not intended. So they must be classified as a good binary. And this is the major reason the market about 10 years ago shifted to behavior-based detection, because the idea is that, well, we can't say that WMIC is bad. However, we can try and detect whether it's behaving badly, and that is really how we're going to prevent attacks going forward, right? So that sort of shaped so much of our industry over the last 10 years. And as behavior detection has gotten better, the attack change has become almost comical, all right? And I'll show you some of those. So if you look at some of the big attacks like Vault Typhoon, high-profile lol bin usage, they use NTDS-util for backing up domain controllers and exfilling passwords, NetSH for proxy, WMIC for environment enumeration, Xcopy for moving files around, all this great, rich functionality that already exists there and that is already trusted. But one thing that's also to remember is attack groups also have constraints, right? They will run these playbooks, do the next step, and they're humans at the other side in many cases. And, they get tripped up just like anyone else does. I saw a couple of years ago a nation state in a environment that was using MS Build to compile code into memory. They got an executable running on the domain controller. And what tripped them out is they couldn't figure out how to configure the proxy to get back out of the environment. So at eviction time, we were left with the image that was in memory and we were able to actually understand what they were doing. But they will follow the playbook granularly. So one of the best things you can do is trip up that playbook. And when we're looking at attack chains like this, it is a real testament to how good EDR is, right? And I know that, results or experience may vary, but the fact that attackers have to walk through an attack chain like this, it is showing that EDR is really raising the bar. And they're forced to utilize, user identity and become the administrator in order to achieve their goals. So this is a great news story, and EDR is almost sort of necessitated as a result, and the arms race sort of continues. We're living in a really complex space where no longer code's just on disk. So the entire point that an attacker will drop a script, use WMI, use Xcopy to move something around, and do about 10 things to get code execution ultimately is to bypass detection, right? You do a whole bunch of small behaviors over time and you don't ever meet that detection threshold, and it's nearly impossible to actually detect. But this complexity presents more opportunities to actually detect them if we can foundationally cut off some of those building blocks. And attackers still do drop code, but they delete them as they progress. One thing that you can do, which is really simple, I don't know if many of you have heard of the Microsoft utility called Sysmon. Basically what you can do is you can configure it to automatically keep copies of any deleted files, right? And so one thing that I find really useful in incident response is to have Sysmon running on a domain controller with the file archive functionality there. And what it will do is it will actually take any deleted code under a certain size. Attackers aren't dropping 50 megabyte files on your domain controllers. It will copy that to a place on the operating system where you can actually go and catch that. It sits there in the background, doesn't cause you an issue, and it's really good for sensitive systems, just as a incident response protection there, because you have a copy of the code regardless of what the attacker does. So this type of operation is really normalized, and there's heavy, we're not just talking about executables and DLLs anymore, heavy alternative script users. So what we see as the most commonly abused utilities that are actually out there is RunDLL32, used to load in malicious DLL files. It's sort of a critical part of Windows. You can't really get around it. MSHTA is used to load malicious HTA files, which is a lot of sort of HTML code. MS Build is used frequently to reflect code into memory. So what an attacker will do is take an obfuscated version, compile it on the machine, and go straight into memory. So they actually are leaving no compilation of their file on the actual system that they're attacking. WMIC, I'll talk about WMIC in a second, but it's used great rich framework to make Win32 API calls and make the operating system do things for you. And also Bits admin, which is great for used for Windows Update, patching to actually download and transfer files. So WMIC, right? It's still around today. We talk a lot about it. We talk a lot about how attackers are actually abusing WMIC. And Microsoft said that in Server 2012, WMIC is deprecated. We're not using it anymore. That was obviously 13 years ago. And I still think this is true. I was looking before this talk at where we're at now, but there was a deprecation timeline. At the start of 2024, Microsoft said that in a future build of Windows 11 Insider, we're going to disable it by default. That doesn't mean remove it. The binaries are still there. It means that it will be disabled. And it's still in there today, enabled, and I haven't actually heard anything more in the last 18 months on that, right? So WMIC is still there, and there's a reason for this, and there's a reason for Microsoft's success in the market, is they need to make they've got a compatibility problem, you know. Like the one thing that gives Microsoft the edge is you can install a piece of software that was written for Windows XP, and it works on the latest version of Windows 11. And that is a really hard thing to do, but you get constraints like this that makes them move at glacial timeframes. And that's just a reality of you know, even though there is a ton of pressure and a ton of pain being worn by something like WMI, it's still really hard to remove. So we need to cut classes of attacks. We need to look at how can we take these blocks away, and what we want to do is proactively remove classes of functionality. If you don't use MSHTA, then proactively block it and force the attacker to bring their own code. Be aware about features on demand, though. If you actually go and uninstall or turn off a feature, and attackers on a box, they can actually turn the feature back on. And this is really the principle of Microsoft's attack surface reduction rules. I don't know if any of you have actually seen the ASR rules, but it's still pretty limited. It's still pretty limited, but if you tick the boxes on those, they're definitely worth turning on. But why don't we build further on the rules that are available? Because there's only about 10 or 12 that are actually there. And I think this is the best value that you can do, because you only need to trip up the attacker once to stop an attack. But how do you do this? You can't just delete the code, because Windows will also repair itself. It'll say files are missing and it'll just put it back. So what we need to do is restrict these utilities to trusted loaders or their parent accounts. And you know, you can use EDR software to do this. So the CrowdStrike IOA rules or custom IOC rules are really useful for those of you that are CrowdStrike customers. And also using even stuff like semantic, you know, you can actually go in and you know, start to determine how to allow binaries and what's allowed to use them. Allow listing obviously is a great way to do this, but the one thing that makes this practical at scale is you have to have the ability to monitor and also test your implementation. So what you need is the ability to audit the usage of a particular binary, right? You can do this with Sysmon that I talked about before. You can do this with the EDR tools. Just put a watch on a particular large binary that's all you see appear in all of these attack chains in, you know, great security talks around. Audit the usage of it and understand who or what is actually running this binary. So which users are using it or what is running it, right? And then what you want to do is scope this. So you need to refine these rules to exclude known good behaviors. One thing that uses WMIC a lot might be Cisco VoIP soft phones that might be installed on your environment, or printers are a really big thing. If you can refine it to the parent that is calling it, we can just sit there and watch and start to build a pattern about what we're actually using it for. You need to then communicate to your technical departments about what to expect when a particular block occurs, and then you need to move to enforcement. So you migrate rules to a proactive blocking implementation, add exceptions as required. But we continue to pick on WMIC here, but how often do users implement and invoke WMIC? Only you can answer this. Every environment is different, you have different requirements, and vendors cannot do this for you. So set up the logging, and that is just the step one. At least you have the visibility there. And as I said, old printers and things are generally the things that use it. And they're slowly being replaced with WMI commandlets and PowerShell, but you know, the functionality, as long as the binary is on disk, it's a problem. So one thing that you can also consider, which is a great attack reduction in your environment, is at minimum scope network communications through host-based firewalls. If you have a on-prem environment, or you can generally scope when you're inside your environment, your desktops to communicate to only the servers that are required, and vice versa. All right, that takes logging and time to set up, but it stops attackers from moving laterally, and it's really effective takes a bunch of work, but restrict binaries to private address spaces if possible. This can be done out of the box with CrowdStrike Falcon, Windows Firewall, and many other players that are there, right? So it's just about defining what software can do from a network and also an execution point of view. So really, to execute on this work, visibility is critical. You have to be able to see it. So use these tools that you have available in order to get that visibility. You need a framework to prevent file load. So have a look at what capabilities your current endpoint protection tools you have in place. Look at something like WDAC. WDAC's a bit of a monster. There's a reason that we exist as a company to make allow listing easier at scale, but it's hard to configure. But WDAC is really well primed actually blocking individual files, right? You can't get to an allow list approach practically with it, in my opinion, but you can use it to take binaries off the table. And it's in there in Windows 11 as a native capability. But you need the ability to soft test first. That's what's critical. And as I said, you can't just delete those files. Binaries just get added back through the Windows patching system, and they must still be observed first. But there are a couple of additional things that we can do. When you're building your SOEs, use the DISM tool from Microsoft to actually disable features that you don't need at packaging time. As I said, use Windows long-term servicing build. There's just less code in them by their nature. So even if you're using 23H2 or 24H2, switch over to the enterprise build as soon as you can. Deploy Windows Server Core as much as you can. As much as GUIs are lovely and we love to remote desktop into things, with different management methods, getting used to OpenSSH and the command line is often more useful. And the attackers love GUIs as much as anyone else. The amount of lateral movement by really sophisticated nation-state groups is just RDP. And if they can't RDP into the box, in many cases, you're actually really slowing them down. There's the LOLBAS project, which is out there. So this is a great open source project that actually lists the number of LOL bins that are actually out there in common operating systems, what they are, and some of the attack surface there. So that's a really great resource if you want to start to look at what binaries are there. And also there's a project on GitHub from Chris Titustek called WinUtil. And what that utility does is it allows you to strip out features in Windows, and he's done all the work to actually have the PowerShell code behind it to allow you to remove these things in a really convoluted way. I wouldn't suggest that you use the GUI, but look in the repo and have a look at the individual PowerShell commands, which might provide you a shortcut to actually stripping out certain parts. That's where the value really is in that project. And also have a look at Microsoft recommended block rules. There's an article that's called Applications That Bypass WDAC. So these are utilities that will get around and are commonly exploited by attackers to get around things like application control using the Microsoft ecosystem. But I think we spend a lot of time talking about attacker methodologies at security conferences. There's great research out there, and this is really important to understand who our adversaries are. But I would actually argue that it's not worth the investment in your energy. EDR tooling does this on your behalf, right? That's what the company's set up to do. That's what the research teams are there to do, right? What, as practitioners inside environments, the best thing we can do is focus on the hardening piece and taking chips off the table through functionality. So focus on that foundational attack surface reduction is really my recommendation. From Airlock as a company, we've got this feature called block listing, where it makes it really point and click easy to block inbuilt functionality mapped to the MITRE ATT&CK framework, mapped to a number of different binaries and different LOLBAS techniques that you can go in and import those things and simply observe and then block and harden your operating system. So, our job is to make it actually really easy to point, click, report, and measure and evaluate and try and get that attack surface down on your endpoints. And of course, we do allow listing as well, so deny by default, and that's the only thing that we do as a company. So you can find out more at airlockdigital.com. You can swing by our booth, which is just over there. It's actually on the other side of this booth just here with the pinball machine. So if you want to learn more, get a demo, or just talk and nerd out about everything Windows internals, I would love to have a chat. So I hope some of those takeaways were useful to you, got you thinking a little bit about where you might want to focus some energy in defense. And thank you so much for your time. Cheers.